The purpose of this video is to explain and demonstrate how to find the area of a triangle. Now, a triangle is actually half of a rectangle or a parallelogram. I mean, if you look at this rectangle here, just by drawing a diagonal line like this, I was able to create two right triangles. I mean, I could put a little block here to show this is 90 degrees and a little block here to show this is 90 degrees. Here we have an example of a parallelogram, and with this parallelogram I was able to draw a diagonal and I was able to create two triangles, and just by eyeballing these it looks like these triangles are probably going to be about less than 90 degrees each of the angles, so they're probably going to be acute triangles. But anyhow, I just want to get it straight that a triangle is half of a parallelogram. It's half of a parallelogram. It takes two triangles to make a parallelogram. Now, the formula for finding the area of a rectangle or parallelogram is A equals BH. Now, in another video I explained this formula, but here I'll mention again. A is area, B can stand for base, or if you rather, the length, and H is the height or the width. Now, when you have two variables like this B and H side by side, you know that you have to multiply. When you replace the B with the number that is the base, the measurement, when they replace the H with the measurement that is the height, you multiply them and it gives you the area. Now, it makes sense when you realize that the formula for finding the area of a rectangle or parallelogram, if its area equals base times height, and a triangle is half of a rectangle or parallelogram, it makes sense that the formula would be 1/2 times base times height. Base times height. Now, when you multiply a number by 2, you're essentially dividing it by 2, just to keep that in mind. Now, I've seen other people do this formula where they would write it down, area equals base times height, and then they'd have a fraction bar, and then they'd have a 2 as the denominator to show that base times height is divided by 2. Because when you multiply by half, you're essentially going to be dividing whatever the product is from the base and the height, you're going to be dividing it by 2. Now, here we have an example of a right triangle, and I can put a little mark there to demonstrate that that is a right triangle. Now let's put some measurements on this triangle. Let's say that we have this side here at 13 inches, and we have this side here at 16 inches. Now I know that we can use theorems and all that kind of stuff to figure out what this line should actually be, but just for the sake of demonstrating how to find the area of a triangle and keep this video less than 15 minutes, I'm just going to make up numbers and just plug them in with the formula. Actually, I don't even have to give this a measurement because all I'm interested in is the base and the height. So this would not even be into play, so I'm just going to leave it off for now. Now, anytime you have a right triangle, this line is going to be your height. Now, I always consider the base the line that is perpendicular to the line that makes up the height, and so this will be our base. 16 is going to be our base, and 13 is going to be our that's not a very good multiplication symbol, but there you go. And 13 is going to be our height. So area equals half times 16 times 13. And if I multiply 13 by 16, that's going to give me 208. And then when I times 208 by half, remember it's essentially dividing it by 2, I'm going to get 104, and my unit measure is inches squared. So this is how you can find the area of a right triangle. Now, a lot of students, they want to see a line that's drawn separate for the height. But when you have a right triangle, this forms the height. This forms the height. So you don't have to have a separate line representing your height. Let's go ahead and look at another example. All right, here we have an equilateral triangle where all the sides are the same length. This one here, we could say that this is going to be 20 feet. This will be 20 feet. And this will be 20 feet. Now, do I have enough information in order to figure out the area of my triangle? And the answer is no. While I know how much all the sides are, unless I know that height, I have no idea. I cannot get the area. So what I'm going to do is I'm going to go ahead and I'm just going to plug in 15 feet to be the height. Now, I'm sure somebody could do the math and figure out that's not going to really be the true height, but just for demonstration purposes, I'm just going to write 15 there. So area equals 1/2, and the base is 20, times 15. So all I have to do then is just say 20 times 15, and that's going to give me 300. And then I'm going to multiply it by half. And when I multiply it by half, I'm essentially dividing it by 2. And that's going to give me 150 feet squared. Now, I had a student the other day who was trying to do this type of problem. And what they did, instead of writing down this part, they said 300 divided by 1/2. Now, that's not the same as 1/2 times 300 at all, because if we were to work this out, I would make this an improper fraction, and then 300 over 1, and I times, and then the inverse of 1/2, 2 over 1, which would give me 600 over 1, which would be 600. And this is completely wrong. We need to be sure that we multiply 300 by half, and that's going to give us 150. Now, if I actually did work it out here, I could go 1/2 times 300 over 1, making an improper fraction, and then I could say 300 over 2, because 1 times 300 is 300, 2 times 1 is 2, and then reduce that down to 150. So be sure that you keep it straight, that you multiply 1/2 by your base and height, and that you do not try to divide it. Otherwise, you're going to get a completely wrong answer. Okay, let's go ahead and do some more examples. This time we have an example of an obtuse triangle. And what we've done here is we have extended this base to come out to here to where it's perpendicular with this this vertex here, and I can draw a line down here, which is already done for me. I did this previously, and this will give me the height. Now, I can say that the length of this side, I can say that we'll say that it's 15 millimeters. Let's say at this side, we'll give it a measurement this time. Let's say that that's going to be 30 millimeters. And let's say that our height from this point to this point, let's say that that is going to be 20 millimeters. Now my formula is area equals 1/2 base times height. Now area equals 1/2, and my base is this line here, which is perpendicular to the height line, and it's 15. And my height is 20. Now 15 times 20, it's going to give me 300, and I know 300 is times half. It's going to be 150 because we did that one a moment ago. Those, we wound up with that same thing. All right, and it's millimeters squared. Now, I know a lot of times you may see an obtuse triangle like this, and we say it's an obtuse triangle because this angle is greater than 90 degrees. is flipped over to where 30 would be the 30 would be the base. And if that was the case, then you'd probably see a height line that would go from here to here. Because if this is the base, the height line would be perpendicular to it. Alright, let's clear that. And let's do an example like where you could see the base like this right here. Now, I'm going to go ahead and for this one here, I'm going to put 50. I don't think I've used centimeters yet. And here, I'm going to go ahead and put that down as 30 centimeters. This one is 30 centimeters. And this one here, and this is our height line. And I put this in previously. That's the 90-degree angle. We can make this 20 centimeters. Now, our formula is area equals 1/2 times base times height. Area equals 1/2, and our base would be 50 centimeters because it's the line that is perpendicular to our height line. So 50. And our height is 20 centimeters, so it's 50 times 20. Area equals 1/2, and 50 times 20, of course, is 1,000. And half of 1,000, if we times 1,000 by half, is going to give us 500 centimeters squared. So, one of the things I hope to take away from this video is that the area, the formula that we use for a triangle, is just like the formula that we use for a parallelogram, except for where a triangle is half of a parallelogram, we only need half of the area of a parallelogram. So that's why we have area equals 1/2 times base times height. Thank you for watching this video. I hope it was worth your while.